Welcome back. We're going to work on a another model, 8.6 example, retirement planning model. So it puts the data and assumptions, and this is how much retirement contribution we're making. So assumed 8%. What percent of that is the employee match? So they're not putting in 35% of our salary, they're putting in 35% of whatever we put in. So it's 35% of the 8% that the employer is putting in. We made an assumption on our average salary increase. We made an assumption on our annual rate of return, and I put a note out here. Anything in italics are things that I've kind of added to what the book has in the model. You want to make sure you're assuming whether that's before tax or after tax. I put after tax. You can change the assumption. I mean, that's the whole purpose of the model. I added in here what a starting salary was, what a starting age was, so that we could model, and if we had any savings to start with, because that becomes important, because the example in the book assumes that there's no savings to start with, which may not be the case. So down here we have the model of results, and again, this age is just linked to whatever I assumed the starting was, and then you can put down here is whatever the cell above plus 1, and then I just filled that down. The salary line is the starting salary line. Then the following year is going to be whatever my savings balance was, or whatever my salary last year was, times 1 plus my salary increase. So this is 1.3% greater than what I had before. So, as you can see highlighted there, my salary the prior year times 1 plus whatever the increase is. And the reason for the 1 plus is obviously the 3% would just give us the amount of the raise. The 1 plus will give us the base plus the amount of the raise. The employee contribution was simply my contribution level, 8%, which you'll notice we put dollar signs around because we want to lock that. So when we fill it down, times whatever our salary is, which we didn't want to lock because we want that to increase as our salary increases. Same thing for our employee contributions. That was simply how much the company matched, 35%, times whatever our employee contribution was. So our employee contribution is 8% of the 50,000, which is 4,000, and now our employer contribution is 35% of that 4%. Our savings balance is simply our starting balance, starting saving balance. This is a little different than what the book has because I've assumed a starting savings balance. So the starting savings balance times 1 plus whatever our annual return is. So that gives us what our starting grew to be, plus any contributions we made. C15 plus D15, our employee contributions and our employer contributions. So the first half of this equation is saying, well, if you started with some savings, you earned some interest on that, so that grew, plus anything you saved in those periods. Now, down here, notice I changed this around a little bit. Our next cell is going to be whatever we had in the previous savings balance plus what we earned, and we locked those in because we want our 8% to stay as an absolute cell, plus whatever we earned in the two saved for employer contributions and employee contributions, and then I filled those down. Okay, so there you see. And you can fill this down to, a retirement age if you wanted to. There you see at 44. And notice it grows quite handsomely. It's kind of encouraging that it grows very, very slowly. If you've taken personal finance, you understand that it really starts growing quite fast as you get older. Any questions? Let me know. Let's take a look at the 8.7 example, the retail pricing markdown. Now this is where an example where firms have to make a decision of how much to reduce their prices by. So again, it's a fairly simplistic model, but it gets more complicated as we go along. So our assumptions are our retail price, what are we selling it for? How much inventory do we have? How long is the season? 50 days, 40 days of which we will sell at full price. 10 days we'll sell at the intermediate markdown price, the difference between 50 and 40. And what is our markdown clearance price? 70% off list. They give us a demand function, which is our A, our y-intercept, basically the amount sold at a price of 0. And B is our slope, if you remember your algebra. For each $1 increase in price, quantity demand falls by 1.2. Or in other ways, for every $1 decrease in price, our quantity will increase by 1.2. So our model, our results, here's our full price, which is nothing more than a copy from above. Now, our daily unit sales are going to be a combination of our demand function, daily sales in units. Now, this assumes that we don't sell out all our inventory at first. I've tied it to their model. They're assuming that we won't sell everything at full price. You'll see later it has to be a minimum of whatever our inventory is. Theoretically, if our demand was more than 1,000, then we wouldn't be. Technically, we should have the minimum between the inventory 1,000 and demand. But in this case, the book is assuming that at full price we wouldn't sell all our inventory. That's why it's just the demand function in there. So we're selling, remember our demand function is sales per day. So we have 7 sold per day times the number of days in this days at full price, 40. So the number of units we sold is the minimum between, well, here I put it in, the minimum between sales in units times the number of days or the number of inventory we have. The minimum of those two. So we sold 280. So our retail sales is going to be our 280 times our retail price. Off to the side, I just put a footnote. Inventory left is simply going to be our beginning inventory of 1,000 minus our 280. So that tells us what our retail was at full price. Now at discount price, we're discounting it by 30%. So our price is going to be full price times 1 minus the 30%, because remember, the full price is 70% of the original price, so it's 1 minus the discount. So that gives us, then we take that price, we put it into our demand function. Right? It tells us what the demand function is. That tells us how many units we sold. And again, it's the minimum between how many units we have on hand, which is now 720 inventory left, because we already sold 280, remember? So we sold 320. Then to get the discount price, it's simply that 322 number of units sold times the discount price. The last piece is our clearance pricing, which is simply our list price times 1 minus the discount level. Same sort of thing we do, but here we do the maximum of, there may not be any left, the maximum of what's left. Now this model is assuming that at the clearance price we will sell all our inventory. Later on, we might change that assumption. For now, it's assuming that at the clearance price, everything will sell. Therefore, we have our clearance revenue is going to be our clearance price times the number of units we sold. And our total revenue is just going to be the sum of the revenue at full price, intermediate price, in clearance price.